In this video, we're going to be taking our final look at using the law of sines to find missing measurements in a triangle when what we are given is two side lengths and the angle that's not included between them. So once again, we're looking at SSA. And in this triangle, we're given a 63-degree angle, a side length of 12, and a side length of 11. What I'm going to do, of course, is quickly label this. So I'm just going to call this angle A. This is side A. I'm going to call this side C. I'm sorry, side C and angle C. And I've got angle B up here and side B opposite it. And I'm going to use the law of sines. Let's see, what can I do first? I've got A, and I've got side C, so I can find angle C, and that's what I'm going to do first. So I'm going to say, A over the sine of A, and I think you don't mind that I'm just kind of going ahead and plugging the numbers in, equals 12 over the sine of angle C. And again, when I cross multiply around, I'm just going to kind of cover this up to see what's on the diagonal. So now I'm going to have, angle C, the sine of angle C is equal to 12 times the sine of 63 degrees divided by 11. Now, for probably the first time, I'm just a little concerned that this is going to end up being a number. If it's bigger than 1, there's going to be no angle measurement that goes with this, and we saw that was a possibility before. However, this time we end up with 0.9718, and when we do arc sine on that, we get a reasonable angle measurement of 76.4 degrees is what angle C is equal to. Gee, it sure looks like it's about 76.4 degrees. I'm going to put that right here. Okay. Now what we could say quite easily here is that it would be easy to find angle B. So we're going to say angle B equals 180. Once we have two angle measurements, we can easily find the third. And here we're going to get angle B is equal to 40.6 degrees. And if we use the law of sines again, we have 11 divided by the sine of 63 degrees equals B, which we don't know, over the sine of 40.6 degrees. And when we do that calculation, we get an answer of B equal 8.04. Again, I'll kind of leave that up to you to find. And when I put that measurement up here, everything seems pretty okay. Let me put 40.6 here and 8.04 here, and everything seems fine in terms of being proportionate. Well, of course, that's how the law of sines works. Now, there's only one problem with this, and I will demonstrate that on the next page. Okay, now keep in mind that the information that we were given was this was 63, this side length was 12, and this side length was 11. And when we find our angle measurements and side lengths, they seem to make sense. However, this is a situation where there's more than one possible answer. It's very difficult at times to determine whether that's the case. Very quickly, however, I'd just like to show you that this could still be 63 degrees, and this side length still be 12, and this side length still be 11, but the 11 could be drawn this way. So again, I'm kind of trying to show you that if this side length is the same as this, that this could very well be the triangle that we're finding right here. It's very difficult to determine this just by looking at the drawing, but instead of this triangle being shown as diagrammed with these measurements, we can now imagine that this is 11, that's 12, and this is 63 degrees. Side B is going to be much smaller than it is here, and angle C, which is no longer shown here, is going to be bigger. Here it's in the 70s, and here it's going to be an obtuse angle. Now, how can we tell that this is going to be the case? That takes a little bit of time, so let me just very quickly kind of go back to our original calculations. When we first calculated angle C, we got 76.4 degrees. Now the problem is that when we do arc sine on a decimal number, our calculator would actually like to give us two angles. There's the 76.4 degree angle, and then there's also the equivalent, the angle that has the same reference angle is 180 minus 76.4 degrees. These two angles are going to have the same, that would give us 103.6 degrees. These two angles have the same decimal number. Our calculator only gives us this one back. When we ask it for an angle measurement that goes with this decimal number, it brings back the acute angle. It would bring back this angle as well if it could. So we're just going to check now to see what if it really meant 103.6 degrees. Could we still have a triangle? Here's what we have to think about. If this is 103.6 degrees instead of 76.4, if we assume that this is what our calculator wanted us to think of as angle C, is it possible to still have a triangle? So we take our original measurement for angle A, which was 63 degrees. If angle C is now 103.6 degrees, can we still have a triangle? Do we still have an angle measurement possible for angle B? Yes. 180 minus 63 minus 103.6 gives us an angle measurement for B, which would be 13.4 degrees, making angle B smaller than it was previously, which would make side B smaller, but please understand we haven't changed any of our original information. 63 degrees, 12, 11. Yes, angle C is now 103.6 degrees. Angle B is smaller than it was when we worked it previously. We've got two completely different triangles. Except for our given information, they really couldn't be more different. When we find B using our law of sines, again, we've still got 11 over the sine of 63 degrees equals B over the sine of 13.4 degrees. We get side B equals 2.86. So it's actually quite small. This is a situation where SSA gives us two possible triangles. And this is called the ambiguous case, meaning there's not enough information to be definite about exactly what kind of triangle we have as a result. Now, this is going to raise some concerns for you because you're going to be worried that you'll always have to check for this. Again, you only have to check for that when it's SSA. And to be honest, use a little bit of judgment on this. I think it might be helpful if you just do a quick sketch and try to imagine, could you draw it a different way, and then try for your two possible triangles. Actually, what I'll do is give you a few examples in the next video of calculations which might indicate that you would have to check for two possible triangles. This is still using the law of sines.